Hello guys, JP Media over here. I will start a series called Web Applications 101. This series can be watched by both beginners and those who have experience working in web applications and want to see their understanding summed up. Okay, ready? Grab your coffee. Okay, so let's start with the client. What is a client? Actually, before that, what is a client in the real life? In the real world, when you enter a restaurant, you are a client because you order food on your table. You request something to be provided to you, whether it is a steak or a burger or chicken. Okay, anyways. In the wild world of the internet, it's not that much different. A client also requests resources. The video you're watching right now, for example, is a resource. A client can be a web browser, an application on your mobile device, or even a curl command line tool. And most importantly, a client should be connected to the internet. When you open a web browser and navigate to a website, you are using a client to interact with that site's server. Similarly with the others, the client will interact with a server to request resources. The client will take user interactions, such as a button click, and translate them into requests to a server over the internet via TCP/IP protocol. TCP/IP is a standard for transmitting data over networks between computers. We have a mini series for it on YouTube if you're interested in learning more about it. Okay, for now, all we need to know is that this request travels the world and somehow reaches our server. Okay, so in the internet, we have many computers which are communicating each one to another.
Hello.
So, how does each computer on the network identify itself? Well, via TCP/IP protocol, each computer on the network will get assigned a unique IP port combination. You can think of it like your national ID. With this unique IP port combination, a computer on the internet easily identifies itself. Example. Okay, let's have an example. Let's say this is JP's computer here and it wants to communicate with Supergram's server. Okay, first of all, Supergram should have its public IP known to everyone on the internet. Then JP's request will have as source IP and source port its IP and its port, well, obviously, and as destination IP, destination port, Supergram's IP and Supergram's port. Okay, Supergram's IP can be anything, but the port would be typically 443, which is reserved for HTTPS. The port number is a 16-bit integer. For the client, it identifies the specific process which requested data from the server. For example, on the same machine, if I have a browser communicating to Supergram and a curl command also communicating to Supergram, a different port will be assigned to each process. The port number assigned to the browser will be different from the port number of the curl command. So that's the role of the port number. If you ever thought why we need a port number in addition to an IP, you can think of it like the IP is assigned to the network interface card of your machine, but the port number uniquely identifies each process in your machine. The port number range differ for the client and the server. To the client, the range can be from 1025 to 65,535. The server would use typically known ports. For example, the port 443 for HTTPS, the port 80 for HTTP, the port 22 for SSH. So it would typically use these port ranges, which are less than 1025. Okay, so regarding the server, actually we mentioned Supergram's server several times, but what exactly is a server? How does it differ from clients? A server will also be another computer connected on the internet, just like the client. And also, just like the client, it will get assigned a unique IP and port. However, as previously discussed, the port range of a server would typically differ from the port range of the client because a server will use dedicated ports such as 443 for HTTPS. But unlike the client, which can be connected to the internet at whatever time it wants, the server have to be always connected to the internet because it should be able to serve requests at any time. Imagine, for example, Google servers available at one time of the day and unavailable in the other time. Well, of course, it will not happen. That goes without saying that servers should have more robust hardware configurations compared to clients. So servers would typically be stronger computers, not your typical laptop. On the server, a special server software would be installed, and this software's responsibility is to respond to incoming requests from the browser. A server is not only limited to hosting websites, but can also talk to other servers, for example, a database server or third party integrations. When a client device wants to access a web page, a copy of the web page is downloaded from the server onto the client machine to be displayed in the user's web browser.